As Node.js projects grow, raw Express applications often run into a wall. What starts as a simple server quickly becomes a sprawling, tangled web of routes and middleware, getting harder to maintain with every new feature. That is where NestJS comes in. It takes the unopinionated nature of Node and applies a strict, Angular-inspired architecture to keep your codebase organized, no matter how large it gets. This diagram illustrates the stack. NestJS doesn't reinvent the wheel. It sits right on top of Express, or Fastify if you prefer, wrapping those fast servers in a highly structured TypeScript-first layer. Over the next 6 minutes, we will build the foundational scaffolding, define our application routes, and isolate the business logic using the modular patterns required for large-scale production applications. Let's look at the terminal. We start by installing the Nest CLI globally with npm IG at nestjs/cli. Once that finishes, we generate our new project by running nest new myAPI. The CLI generates a complete project structure for us out of the box. If we open the newly created src folder, the most important file to look for right now is main.ts. Inside this file, we call the nestfactory.create method. This is the entry point that actually bootstraps the underlying HTTP server and gets our application ready to listen for incoming traffic. Running npm run start boots up the local server. Navigating to localhost 3000 in the browser returns a simple hello world, giving us a functional baseline to start building our actual features. To turn this baseline into a working API, we need a way to intercept incoming HTTP requests and route them to the right place. In NestJS, that is the sole job of a controller. We use the CLI to generate a controller specifically for our new feature. Once it is created, we clear out the default boiler code to start with a clean slate. This code snippet shows how we map our endpoints. By importing decorators from the @NestJS common package, we apply an @controller tag to the class, and then attach @get and @post tags to individual methods inside it. When clients send dynamic data to these routes, we extract it directly inside the method signature using corresponding decorators, like @param for URL parameters and @query for query strings. Controllers excel at managing traffic, but they are not designed to process complex logic. For database calls or heavy calculations, they must pass the request downstream. That downstream destination is the service. Services are a type of provider in NestJS, specifically designed to isolate your logic and database interactions completely away from the routing layer. To make a service usable across the application, you must mark it with the @injectable decorator. This registers the class with Nest's inversion of control container. This flowchart breaks down why that matters. Instead of a controller manually instantiating a new service every time it runs, which wastes memory, the inversion of control container manages a single shared instance. It then injects that exact instance directly into the controller. Looking at this constructor snippet, we implement that injection using a TypeScript shorthand. By simply adding the private keyword in front of our typed service, Nest automatically declares and initializes the property in one step. With the service successfully injected, the controller's route handlers can now just call the service methods and return the result to the client. By separating the routing logic from the business logic, you create independent components. This isolation ensures that even as the application grows, your controllers stay lean and focused only on handling the incoming request. This application graph shows how all these pieces fit together. A root module branches out into isolated feature modules. Each feature module creates a strict boundary, grouping related controllers and services. Inside the module, a controllers array defines publicly accessible routes. Below that, the providers array registers the services to perform the work. A common stumbling block is creating a new service and forgetting to register it. If it isn't in these arrays, Nest doesn't know it exists. Finally, to wire the new feature into the main application, we import this module and add it to the imports array of our central root app module. Encapsulating features this way ensures your code remains cleanly separated. As the project inevitably adds new features, the architecture remains organized and maintainable. This split screen proves our setup. On the left is our modular code structure. On the right, when we hit the endpoint in an API tester, we get a successfully 200 OK JSON response, tracing the request directly through the controller, down to the service, and back. We have now coordinated 3 distinct layers: controllers for handling traffic, services for internal logic, and modules to define the boundaries of the entire feature. However, right now our service is just returning hard-coded mock data. In the next phase, we will replace that hard-coded data by integrating a Postgres database using an object relational mapper, and we will secure our inbound requests by validating them with data transfer objects.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.